Yes, dear viewers, we are now set for example 5. So example 5 is telling us to solve the equations. So the first equation is 2 power x, then plus 4 power y is equal to 12. Then the second equation is 3 brackets 2 brackets power x minus 2 brackets 2 brackets power 2y is equal to 16. Semicolon, hence show that 4 power x plus 4 into 3 power 2y is equal to 100. Now these equations, on inspection, according to when we have seen them, each equation has two unknowns. So there is no way you can solve a particular equation with the two unknowns independently. So this equation can't be solved independently. No, this one can be solved independently. So what does it mean? We have to bring in knowledge of simultaneous equations. Okay, however much here we have not yet tackled simultaneous equations, but let us use the ordinary method of solving simultaneous equations. So among the methods, don't forget substitution and then elimination method. However much we are having other methods, but substitution and elimination are very vital here. So what are we going to do? We shall say, Mr. Examiner, sir, this is our solution. So what am I seeing? I'm seeing we are having 2 power x. I'm extracting the mathematical numerical part into my workspace. So this is 4 power y is equal to 12. I can baptize that as my equation 1. What about the next one? I'm having 3 into 2 power x minus 2 into 2 power 2y is equal to 16. I'm baptizing that as my equation 2. But now, if I'm to eliminate, assuming I'm going to eliminate the component of y, the one which has y, which means I have to go and first make changes in equation 1, such that it first becomes a 2 power 2y. And I'm saying that is possible because 4 is the same as 2 power 2. A 2 will multiply through by y to have a 2 power y. So from equation 1, we shall have a 2 power x, then plus a 2 power 2y is equal to 12. So this is equation 3 now. It has become the third equation. So if that is true, then we can go and see how to eliminate this component having 2 power 2y. However, this component having 2 power 2y in equation 2 is having a coefficient 2. So we must establish a coefficient 2 here. So which means equation 3, we can multiply it by 2. If we multiply it by 2 and then add it to equation 2, we shall come up with a very, very interesting outcome. Let us go and see that. We can tell the examiner that equation 2, okay, plus twice equation 3, that we are going to add equation 2. Why are we adding? I'm seeing a negative of the part involving y, and I'm seeing a positive. However, this part, to make it exactly this, we have to multiply it through by 2. Can you see that? If we multiply it through by 2 and we add it to this, a component involving y is going to be eliminated. So I'm using the elimination tactic. Now, if that is true, I will remain with only x. If I have one unknown in a given equation, it is possible to find the value of that unknown. So let us go and extract equation 2 the way we have stated it here in that statement. So talk to the examiner always. We need to know what you are doing, dear viewers and my learners. So in this kind of arrangement, we have a 3, 2, okay, power x. I'm extracting this, okay. Then minus 2 into 2 power 2y. There is no problem if I put the 2y, the power 2y exactly onto 2. No problem. This is equal to 16. I'm adding this. I will show the addition. The mistake you can make here is multiplying this 2 and this. They cannot multiply because this is already having a padlock and an index. And this has no index. So you have to put the rules, apply the rules. If you want to combine them, apply the rules, the laws of indices. Same base, raised to one base, add the powers. And then it becomes 1 plus 2y, if at all you need to do that. You cannot multiply this 3 by this 2 power x. A 2 is already given a padlock, power x. A 3 cannot open it. Reason being, even they are not the same base. There is no mathematical law you will be applying there. I want to be categorically clear here. Is it okay? So, let us go and look at our statement. Twice equation 3. So equation 3, we are multiplying it by 2. So this is going to become twice, this is twice, even this is twice. Don't forget that because it is you who has established that change. So let us go and see it. Twice of 2 power x, okay. Then plus twice, okay, of 2 power 2y is equal to twice of the right hand side. And the right hand side has a 12. So twice of 12 is 24. Good. That is a 24. Very good. So we are adding. So when we add, dear viewers, what do we get here? Add this. Assuming that 2 power x is like maybe a box. So 3 boxes plus 2 boxes. What do you get? You get 5 boxes, but the box is a 2 power x. Negative 2. Maybe pens. A 2 power 2y, assuming it is a pen. So these are going to be negative 2 pens plus 2 pens. Then the pens will disappear. So we shall get a 0. So plus 0 is equal to 16 plus 24. What do you get? We shall have a 30. Oh, it is a 40. It is going to a 40. So this is a 40. So what we have got is 5 into 2 power x is equal to 40. Okay. We can remove this 5 because I'm saying 40 is divisible by 5. So we can divide through by 5 by 5. So we get a 2 power x is equal to 40 divided by 5 is 8. But by prime factorization, we already know that 8 is 2 power 3. But I can repeat it for you here. Okay, by 2, 2, by 2, 1. So we are seeing that 8 is the same as 2 power 3. So we can go and say this implies that 2 power 3 is equal to, rather 2 power x is equal to 2 power 3. Since the bases are the same, automatically the powers have to be the same. So therefore, okay, or this implies that x is equal to 3. That is very good. Now, if x is equal to 3, we can get one equation. Substitute the value of x, and then finally form the value of y. The value of y. So, which equation is that? We can think of equation 1. So, talk to the examiner. That put means examiner, or putting, because you are not commanding him. Putting x is equal to 3 in or into equation 1. Talk to the examiner. But speed, you should mind of the speed. Or you can tell him substituting for x in equation 1. Very interesting matter. So if we do that, what are we going to get? Equation 1 now is going to become, we can divide this space and then use this left-hand space. So 2 power x, okay, plus 4 power y is equal to 12 is our equation 1 for those who are not recalling equation 1. So we go to our command. The command is putting x is equal to 3. Where there is x, we are putting 3 in this equation. So this is the same as 2 power 3, okay, plus the 4 power y is equal to 12. So this is the same as 8. Okay, 8 will go the other side. And then we get a 4 power y equivalent to 12 minus 8, which is a 4. This is now 4 power what? 4 power 1. The bases are the same. Don't go ahead again to simplify to base 2 base 2 because we have already got the same bases. Compare the powers. So therefore, all this implies that y is equal to what? To 1. So therefore, x is equal to a 3, while y is equal to what? To 1. So this examiner again gave us the hence part, that from where we have stopped. That is the meaning of hence. Where you have stopped, can you continue? Unless if you add the word otherwise. If he says otherwise, hence or otherwise, it means you can continue with where you have stopped, or you can use any other way, that is otherwise. Otherwise. So in that kind of arrangement, we can go and see what the examiner needs us to prove. Left-hand side should be equivalent to 100, which is the right-hand side. So let us go and say right-hand side, no, left-hand side. Left-hand side, that is the hence part. We need to remind him that Mr. Examiner, sir, this is the hence. So hence, left-hand side of what you gave us is a 4 power x, then plus a 4 into 3 power 2y. We need to substitute our values of x and y and see whether we come to the right-hand side. So this is now going to be a 4 power 3 value of x into 4 into 2. Oh, this is not a 2, it is a 3 into 3. Okay, into 3, 2 into the value of y, which is what? 1. So simplify this. 4 power 3 is 64. So this is a 64 plus 2 power 2 times 1. 2 times 1 is a 2. 3 power 2 is a 9. Good. 9 times 4, 36. So we put a 36 here. So when we simplify, we shall get 100. So the left-hand side is equal to 100, which was the same as the right-hand side. So as required, this is a mathematical symbol. A square with a dot centered means as required. So dear viewers, this is the examination type. Example 4 and example 5, examination type. Let us move with more examples. Since you are new to this, you need as more examples as possible. Meet me or get me on the next exam. Dear viewers, we'll be back from the break. We are progressing slowly by slowly. We are now coming to the end of this concept of indices. I'm about to give you answers. Don't expect anything more. What drives indices are the laws of indices. So if you memorize the laws, apply the laws. Get as many trial questions as possible to gain confidence. So solve. We are solving this equation. So how do we solve? We come and say, Mr. Examiner, sir, this is the solution. So in our solution, okay, we extract the numerical part. That is 3 into 3 power x squared, then plus 2 into 3 power x minus 1 is equal to 0. However, on observing this equation, I'm saying 3 power x can be simplified. Okay, can be let to be one unknown. We can let it to be p. So we can let, okay, 3 power x become p. Where the 3 power x, we shall put p. So this implies that I'm having 3p squared, then plus, okay, 2p minus 1 is equal to 0. Since this is a quadratic equation, which you can now factorize. I'm not going to take you through the process of factorization. I explained it earlier in example 4, I think. So, in this kind of arrangement, okay, if we factorize this, I'm seeing 3 times negative 1, that is negative 3. We get two numbers. When we multiply them, we get negative 3. We add them, we get a 2p. And those two numbers are going to be, we are going to be positive 3 and then negative 1p. So when we substitute here, we shall have a 3p squared, so minus plus 3p, then minus p, which will give me a positive 2p, then minus 1 is equal to 0. So from here, I will enclose each in brackets and then add. So 3p squared plus 3p brackets, okay, then plus negative p minus 1 is equal to 0. Then we factorize out the 3p into p plus 1. Okay, then the same here we factorize out negative 1, then p plus 1, p plus 1. So the overall will now be, this is equal to 0. This is going to be p plus 1 as a common factor, 3p minus 1, minus 1. So the only part I wanted is this. I've just helped you to show you how we get it. But what I wanted is only this. So in some coming examples, or in our marking guys, you will see the examiner only including this, because that's the one which takes a mark. So this one can be skipped. All of it can be skipped, and then you put that. So this will give us the value of p. So either, okay, p is equal to negative 1 or p is equal to positive a third. But if p is equal to negative 1, I don't think it will yield any value if we have now a negative power. Let us go and see. So for p is equal to negative 1, this implies that 3 power x is equal to negative 1, which is neglected, which doesn't yield a significant, does not yield significant value of x. So we ignore that. Then for p is equal to a third, as we obtained it here, then this implies that 3 power x is equal to a third. But this one can be now made reversed in the form of 3 power, okay? So this is 3 power x, which now becomes a 3 power negative 1, because the power of 3 is 1 here, so turning it to the original status will become 3 power negative 1, negative 1. So therefore, x is equal to negative 1 if we look at the power. Dear viewers, we'll be back from the break. It is now example 7. We shall give you as more examples as possible. So example 7, let us go and see where it takes us. So the examiner is telling us to solve 2 bracket 3 power 2x brackets minus 5 bracket 3 power x brackets plus 2 is equal to 0. So in the solution, we shall come and say, hope people can pause me, even those who are watching me as a recorded teacher, pause. First work out your answer, then resume the video and see whether what we have worked out is correct. So we have a 2 into 3 power 2x minus 5 into 3 power x plus 2 is equal to 0. So what I can see, I'm seeing 3 power x can be let to be a particular unknown. If at all we cause some changes. So cause a change on this. If you cause a change on this, it will be 2 into 3 power x squared, that we are taking it back from where it came from. To become a consolidated power, it was power. We apply the third law to bring it to a 3 power 2x. So this is minus 5 into 3 power x plus 2 is equal to 0. So we can now let maybe z is equal to a 3 power x. So where there is 3 power x, we are putting z. So this now will become a 2 into z, okay, squared, minus 5 into z, then plus 2 into z. Okay, very interesting. So this is a quadratic equation in z. We can state it well that therefore this implies that 2z squared minus 5z plus 2 is equal to 0. So we can solve this. This time around we are going to use side work such that we can rub it out very fast. So we have a 2z squared minus 5z plus 2. What is disturbing us? We cannot state it at once. The problem is this is not linear quadratic. The quadratic coefficient is not linear. If it was linear, then it would just be a matter of getting the factors and then bring them in terms of z. But if that is impossible, then we can come here, multiply quadratic coefficient, quadratic constant to get a 4z squared. This is side work. And get two numbers, either their sum gives us a negative 5 and their product gives us a positive 4. So these are factors of the product. So we get factors of 4. So we have a 1 and a 4. Then 2 by 2. 2 times 2, we shall also get a 4. So check 1 and 4. If they are all negative, they will bring a negative 5. So we shall come with 2z squared minus, minus what? Minus 4z. Then minus 1z plus 2 is equal to 0. So 2z squared minus 4z brackets, then plus, with their signs, negative z plus 2 is equal to 0. Then factorize out, 2z is a common factor. What remains is a z minus 2. So here, negative 1 is a factor, z minus 2 to go back to the origin. So the factorized format will be 2z minus 1, okay, and then into z minus 2 is equal to 0. So it is only this which we need in our equation at this level. So we come and put it there. So Miss Examiner sir, this now conforms to a 2z minus 1, okay, then into z minus 2 is equal to 0. So which gives, okay, we can change and then remove this part. We no longer need it. It was just side work. That was just side work. Oh. Okay, now let us go and see that either this examiner sir, either z is equal to positive a half or z is equal to 2. So for z is equal to positive a half, remember we said 3z, okay? 3 power x is equal to z. So 3 power x is equal to positive a half. So there is no way we can simplify this in the form of indices. But since it is a positive number, it has to yield to a real value of x. So you think now to advance. We need to advance our mathematics. Think about advancing the math. So we are going to introduce what we call logarithms, and that is our next topic. So good enough, we talked about it in ordinary mathematics or junior mathematics. So we can introduce, tell the examiner that introducing logarithms to base 10 on both sides of the equation. So we shall have log base 10 of 3 power x equivalent to log base 10 of a half. So this x comes this side from the third law of logarithms, as we shall see it, or as you recall it from your junior math. So this will be 3 log base 10 of 3 equivalent to log base 10 of 0.5, because a half is 0.5, which will give you a negative, because this will be log base 10 of 1 minus log base 10 of 2. Okay, so we have x. It is x which came this side, not 3. X came this side, the power. Okay, so divide through by log base 10 of 3, log base 10 of 3. So x will become log base 10 of 0.5 over log base 10 of 3. So therefore our x can be obtained from the calculator, but it's going to give us a negative value, because log base 10 of 0.5 is a negative. So what do we get there? We can come and say that log base 10, log of 0.5. Our calculators are designed in base 10. So it's equal to divided by log base 10 of 3, which is giving us a negative 0.63, okay, 09. So that's what it gives us. How many decimal places? 4 decimal places. We have not used local tables, we have used the calculator. Cal. This is the degree of accuracy. Therefore, that is the first value of x. Then it also implies that, okay, 3 power x is equal to 2. That is for x, for z. For z is equal to 2. So the same applies to this. You will need to apply logarithms. Okay, so this will now give you log base 10, introducing logarithm, 3 power x is equal to log base 10 of 2. X comes this side, such that x now becomes log base 10 of 2 over log base 10 of 3. Okay, so we can go and get that. So log base 10 of 2, then divide by log base 10 of 3. It is a positive value. So x is equal to positive 0.6309. This is to 4 places of decimal by use of a calculator. So therefore, this is our solution. So catch me up on the next example immediately after a break. Hope this is a good posture for you to pause and copy down what is on the board. See you after the break.